This is part 2 of our video on annuities. We were in the middle of trying to come up with a formula for finding the value of an annuity, and we had come up with one that worked for our example that we did, and we were just taking a look at where all the different values came from. So what I want to do is put this into an actual finance formula that we can use. So we're going to use some different letters here instead of A, R, and N. I realize that instead of S, we're looking for the total amount or the final amount. When we were doing our compound interest formula and our simple interest formula, the final amount, we decided to use letter A. So I'm going to say A equals. Now this $100 we said was the payment they were making. Now a good letter choice for payment would be P, but in our other finance formulas, P stands for the principal, and the principal is a one-time deposit. So I'm not going to use a P here because that would be confusing. Instead, what we do is we say that it's a regular payment because it's made on a regular basis, and we use the letter R. It's not my favorite letter choice, but that's the one that mathematicians decided to go with. Now, the 1.04, that's a little bit trickier. This 1.04, I'm going to say is the same thing as 1 plus 0.04. That would give me 1.04. So here, I'm going to do 1 plus, we said that that 0.04 was our interest rate. So I'm going to say it's 1 plus our interest rate to the power of 5. We said that was the number of years. We used the letter N to represent the number of years. That's what we used. I and N are actually from our formula on compound interest and simple interest. And then take away 1 divided by, and that 0.04 once again is our interest rate. So this is going to be our formula for calculating the final amount of an annuity. So I'm just going to mark that A is our final amount, R is our regular payment, I, in both cases here, is our interest rate as a decimal, which means we had to divide it by 100. And then N is the number of years or the number of payments or the number of times that our interest is being calculated. I'm just going to say it's the number of payments or interest calculations. Now the ones here and here are just simply ones. So what we're going to do is see if we can actually use this formula to do some calculations. So we have a couple of questions that we're going to take a look at. The first one here says Omar invests $50 each month in an RESP that earns 9% per annum compounded monthly. How much will he have in 5 years, and how much interest did he earn? So important things in the question. He's doing $50 each month. It's getting 9% per annum compounded monthly, and we want to know how much money is he going to have in 5 years. So when I'm trying to figure out whether this is an annuity or not, I need to look for words that tell me that we're putting money in more than once. And when it says that it's $50 each month, that tells me we're putting money in more than one time. So I know that that's an annuity. So anytime it talks about it being every year or every month, or it might say monthly, I know that that's a good sign that it's an annuity. So my new formula is A equals R times 1 plus I to the power of N, take away 1, divided by I. And I'm going to list A, R, I, N. I left a little extra space for I because we always have to do some work on I. So the $50 is not the final amount. It's actually the amount we're putting in each month. So it's my regular payment. So that's 50. We're doing 9% per annum. So 9% per year. That's my I. And it's being compounded monthly. So that 9% gets split into 12 equal installments, and we always divide by 100 to make it a decimal. So 9 divided by 12 divided by 100 is 0.0075. And then we're doing 5 years, but we're not just earning interest or making payments 5 times. We're doing it every month for 5 years. So since there are 12 months in a year, I multiply that by 12, and 5 times 12 is 60. So all I need to do is substitute all of those things into my formula and calculate. So I don't know A. We decided R was 50, and then I is 0.0075 to the power of 60. Take away 1. Very complicated formula. Divided by 0.0075. Now, if you want, you can actually do this all in one step on your calculator. Assuming you just put your brackets in, you should be good to go. So on this one, I'm going to punch in exactly what I see. I'm just going to push this over a little bit. So I'm going to do 50 times bracket, bracket. So I press the bracket button twice. On this calculator, it doesn't show up any differently, but I still pressed it twice. And then 1 plus 0.0075. I need to close the bracket, to the power of 60 minus 1. And then I close the second bracket, and I divide by 0.0075. And I end up with $3,771.21. Now, if you have a calculator where you see everything on the screen, there we go, it's going to work pretty much the same way. So I would do 50 times bracket, bracket, and then 1 plus 0.0075, close the first bracket, to the power of 60, take away 1, and then close the bracket, divided by 0.0075. And I get the same number. So I get $3,771.21. So how much money will he have? Omar will have $3,771.21. Now that isn't the entire question. The question also wants to know how much interest he earned. And when it asks about interest, it's not asking you to tell me what the rate was. It's asking for actually how many dollars were there in interest. So I know that he ends up with $3,771.21, but I need to think about how much money Omar actually put into the account in the first place. So I know that he was making payments of $50, and he actually was doing it 12 times a year for 5 years, or 60 times. So what he did was he made $50 payments 60 times. So if I do 50 times 60, I get that he put in a total of $3,000 out of his pocket. Now, if he ended up with $3,771.21, that tells me that if I subtract those, I get that he had $771.21 in interest. So therefore, he earns $771.21 in interest. All right, I think we're going to stop there and then pick it up in the next video.